word alignment for sentence similarity. Semantic similarity increases with similar semantic units of similar semantic contexts in monolingual word alignment. So this is take 2 of this video. The first one, the sound didn't work out so well, and also I got a chance to flesh out some additional details and correct a couple of mistakes. So okay, let me refresh. So in 2015, LSTM wasn't widely used and the transformer haven't existed yet. So how even people did their sentence similarity back then? This post is about application of word alignment to semantic similarity. It is about a super simple word aligner based on solely dependency parsing and word database that achieved first place in 2014, fifth place in 2015 in semantic evaluation SemEval STS semantic textual similarity in 2017. Then the aligner dropped to the 10th place, but it still lived on as a subsystem in a winning system in an autoencoder system, while the other spots were taken by LSTM models that started to rise at that moment. Okay, so by the way, hello friend. I am doing this another video. I learned a couple new things. I also started to do more links in my posts. So for example, you can click on this transformer model and you can read more about transformer here. And I have also posted on cross attention, which I spoke about recently. And yeah, I'm happy that you joined again. For others, you can subscribe, and you can subscribe by mail. You can subscribe on YouTube, right? Maybe you see this video on YouTube. You can, connect to me on Twitter and LinkedIn, and yeah, you can send me mail, ask me some question, or highlight some mistake. So quickly, let's go in. So the monolingual aligner paper there's a link over here. You can read the sentence similarity application of this aligner over here. Source code is available. I think it's very performant aligner. I haven't tested it in sense that it runs very fast because it's just a database, and the dependency matching actually you don't need it so much. And it was state of the art in 2014 in sentence word alignment task, and it was it was a winner of that competition on semantic similarity of sentences, and it was 5th place 2015 and so on. As I mentioned, you can also read this overview from 2010 to sentence similarity task. I have a link here as well. So what is word alignment, right? So in word alignment task, we have two similar sentences, and we look for corresponding mappings between the words that correspond or sort of say similar things, right? They have some similar meaning within the contexts. And for example, if we look at this sentence, right, then we have here, the more driving you do means you are going to wait more, or each hour you spend in a car was associated with a 6% increase in the likelihood of obesity. And so you can connect these words. So for example, the more, you can connect to each hour spent. And also the annotators, when they were creating the data set that you need to evaluate and to train then the models on, also had an option to have a link which has a weak connection. Then this was it was like in this in gray, and a sure connection, like the equivalence. So for example, the equivalence here is the car and driving. So this is like the equivalence in the alignment, in the similarity. It stands for the sort of same thing in both sentences. And as well, the means is associated with, right? So it's not necessarily one-to-one, but I think the model itself does the mapping one-to-one later. So what does it remind you of? So I already did this video on word movers distance, which is about earth movers distance, where you have two piles and you have to do some work to transform the earth here we don't count that you have to put the earth, uphill, that you have to bring it uphill. We don't count that. But if you just needed to move earth from one pile to another pile, the minimal work you need to do for the transportation only, that's the earth mover's distance. That's how far these piles are. And you can do the same thing for words that have some sort of embeddings or distances available. And then, so you have two sequences, right, as in the sentences. Those are sequences of words. So the probability distribution support probability distribution, it means as the piles that I will be transporting is over the word vectors of the document words, right? And the value of the word vectors is some normalized frequency or TF-IDF. And then distance between those word vectors is a cosine similarity or Euclidean distance is then the distance on the earth of right distance between those two places, right? So I have two, distance between two places. The support, I have the distribution over the words in the vocabulary, and I'm transporting the earth between them. All right, so let's continue on word alignment. So the word alignment is similar task, right? I'm transporting the words as well in some way. I'm mapping the words as well, right? Except in word mover's distance, I need to also find some sort of optimal mapping, but it's a lot more fuzzy, and I need to say how much I will be transporting where. But here I'm just mapping. I'm mapping what corresponds to what, right? So that's word alignment, how it relates to word mover's distance or earth mover's distance. Okay, so let's continue. Word alignment for semantic similarity, how you can use it. So it's definitely related tasks, right? So if you have two related sentences, you will always be able to align them somehow, right? It makes sense. And actually, the top positions in 2015 sentence similarity tasks before the LSTM transformers were actually taken by word aligners in general. So those were some corpus-based word alignments that either use word embeddings, but in case of this model that I'm talking about, this one just used a database and dependency parsing, and the dependency parsing wasn't necessary. And the database actually was about, it contained sort of equivalent words, the same words. This word is same as this word, this one is same as this word, right? So it just used this database, did word alignment, and some additional contextual mapping, and it sort of works. I will describe the algorithm in a moment. But how exactly do you calculate the score for the similarity? Well, the score for the similarity, you can do it like this, right? You will see that it makes sense that you look at it from point of view of a sentence A, you map to sentence B, and you calculate number of words that I was able to align divided by total number of words in the sentence A. And this is the score. You do it both ways, and then you do harmonic mean. This is the score. Okay, the Sultan Align algorithm in detail, how does it exactly work? So there are these 5 steps in that increasingly align more words. So first we start with the identical word sequences. So if we have some window of same words, you align them. You align the word, I think, in the middle, and or all of them. I'm not sure now. And but in principle, it makes sense, right? So aligned named entities. So here we detect named entities. That's another trick that they used, and also they align named entities with acronyms. Okay, and another step. So then you are able to align more words, right? So more. Another step. The third step is that you align similar words with similar dependency tree context. So this is done in that the similar words are, if they are in the database, dependency tree context is that you also try to match the dependency tree and the words in the dependency tree, and if it all sort of matches, then you greedily select the best matches, and then you align the similar. Next step is that you align. So it's we don't use dependency tree. It's just positional. So if you are able to align. If you are able to align certain window of similar words, it passes sentence core, then you align the words in the middle. And then last step is to align the stop words. So identical sequences, again, if you have long enough sequence that matches exactly, then you align. So this gives you very high accuracy with choice of window size of, I think, 5. I don't have a note here, but I think it's 5. Named entities, so they use this Stanford named entity recognizer GNU licensed. And then they map them also to acronyms. They align to acronyms. Content words. So for example, if you have both sentences, some name, you align that name. Content words. So they used just this simple database, the paraphrase database, right? Where you look for equivalent, where you have same words, equivalent strawberries. So equivalent of word berries. What I'm doing? Okay. Equivalent of word berries is strawberries, and raspberries and blueberries and so on, right? So they use this kind of database to do the alignment. So that's how they define the similarity. And if there is exact word match or lemma match, then it's a 1. And if they find it in the database, they define similarity score of 0.9. Dependency alignment process. So dependency alignment was limited by the accuracy of dependency parser. That accuracy actually improved recently, but at the time it wasn't perfect, right? And without the dependency alignment, actually the model performed like almost the same, but they used it still. So to align dependency context, they had some list of which dependency connections are equivalent, which they just created manually, equivalent for their own purpose of alignment. And so they could be then they were able to find some syntactic patterns in the dependencies and use that for mapping. So for potential unavailable pair, dependency-based context is extracted. Context similarity is calculated as a sum of word similarities of the context word pairs. Alignment score is then weighted sum of the word similarity and contextual similarity. Then we sort of go greedily and align pairs with non-zero evidence greedily. And alignments based on the textual neighborhood. So we extract context, which is set of neighboring content, and okay, there's some bug in my post. And word pairs right, free left, free right. Calculate the sum of the similarities, right, and the alignment score is to use one-on-one word alignment decisions. All right, so the dataset, as I mentioned, is this MSR Brocket 2007 aligned corpus manually created. For example, he interpreted it in his own way. He read into it what he wanted, and then the words are aligned with the two different weights that either you are sure about the alignment, like his own, he is related to he, right? And or he is mapped to he, or is possible alignment. Okay, and SemEval, that's a data set of the sentence similarity. There's score from 0 to 5. 5 means the most similar. For example, the bird is bathing in the sink is the similar to birdie is washing itself in the water basin. So these two sentences are similar, and they can probably be mapped together, right? The bird, I would map it to the birdie, and washing, I would map washing to bathing, right? And so on. So the results in state of the art 2014 on word alignment, and by a relatively good margin, it seems, and sentence textual semantic textual similarity task. It was a winner 2014. All right, so let's connect. If you want, connect to me here on Twitter, YouTube, LinkedIn. I don't know, GitHub. You can subscribe by mail. I have RSS feed, right? And you can you can send me mail or ask me something. All right, so thank you very much. I hope you liked it, and I hope to see you next time. Okay, bye bye.